Good morning, everyone. Thank you for coming to our presentation. An honor to meet you here. Assalamualaikum warahmatullahi wabarakatuh. We are from Group 4 and we will talk about control automatic project. In our group, we will explain about simulation of the stability of the control system on the surface of the liquid. In Group 4, we have a member. My name is Ahmad Fauzan Karnadi, and in the member one, Jad Farras Humaid, Kayla Kamila Ahmad, and the last member is Arie Wibowo Kurniawan. We are from GRM1. In the topic one is introduction. Uh, in the field technology, a controller has been developed that can regulate the flow of the liquid of, or commonly called a liquid volume level controller. So that the use of the liquid or water in accordance with a predetermined dose. This volume level control is intended to avoid liquid overflow. To avoid delay is team between giving order to regulate flow, the implementation or false adjustment, which result in the display of water level indicator giving incorrect price. To avoid placing operation, especially in place where place they are difficult to reach and to react and see, and can provide precision for certain condition such as fixed variable price. The study aimed to simulate the stability of the liquid surface system using the reaction curve method in the Ziegler-Nichols method in the DLP program. After knowing the transient response of the liquid surface system that has been made, the next step is tuning the P, D, and PD control parameter. At this stage, the research used the reaction curve methods in the Ziegler-Nichols method. The use of the method is intended to facilitate research in parameter tuning. Analysis of system response includes the speeds of transient response, the react, the steady state, spike, overshoot to change the reference signal. Noise suppression, performance and variation in the system parameter or change in operation environmental condition. The next step, the result of the analysis are discussed uh, based on exciting characteristic, then draw a conclusion. And this is assumption, and we have inlet is valve, and we have a tanky number one, and we have resistor number one, and tanky number two, and resistor number two, and we have outlet. Okay, next.
Okay, thank you, Mas Fauzan. And for now, I will continue the modern stage. Before that, let me introduce myself. My name is Jad Farras Humaid. Uh, as for modern stage, describe the system input Q equal as steady state speed, parentheses before any change, and the output is H2 equal as liquid surface height in whole meter, and the parameter is R equal as resistance parenthesis S divided M dot 2 variables C equal as tank capacity. Ex- Explain how to get the ordinary differential equation is for the substitution of equation 1.1 into equation 1.2, then obtain this equation. And substitution of equation 1.3 into equation 1.4, then obtain this equation. By using the Laplace transformation of equation 1.5, it can be expressed in terms of S or frequency domain, such as this. And by using the Laplace transformation, equation 1.6 can be expressed in terms of S, such as this. And by substituting equation 1.1 into equation 1.9, it is obtained such as then substitute equation 1.1 into equation 2.1 such as if multiplied by 1 divided r, it becomes this equation. And if h2 parenthesis s is considered as output and qs is as input, then transfer function of the water tank system with interaction becomes h2 parenthesis s divided qs equal as r2 divided parenthesis c1 r1 c2 r2 s dot 2 plus parenthesis c1 r1 plus c1 r2 plus c2 r2 parenthesis s plus 1. And by the end of result, it becomes this block diagram of an open loop system. By using the ordinary differential equation that has been found in the previous explanation, a block of Qs as input and H2s as output and the equation list as part of process can be made. Selanjutnya, Mbak Kayla.
I will present the topic 3, simulation results. But before that, I want to introducing myself. My name is Kayla Kamila Ahmad. These are the parameters value that we use on simulation. The value of R1 is 7, the value of R2 is 5, the value of C1 is 10, the value of C2 is 5. R is for resistance and C is for capacitance. And this is the diagram block and system response. With the block diagram that has been arranged as above and the parameters have been adjusted to which are desired, the system will start calculating the value according to the open loop formula that we enter in the block diagram and produce the data curve shown above.
Okay, now I will explain about control system simulation of PID system. Let me introduce myself before that. My name is Arie Wibowo Kurniawan. So the PID system that we use is more like this. The mapping is with KP, with gain, and with derivative and integral block. And with the disturbance with at time 2000 with final value 20. For the parameter we use is in PID system is R1 as 10, R2 5, C1 is 100, C2 is 50, KP is 2, KI is 0.00068 and KD is 150. By the adding PID, we can determine the value needed to stabilize the result or adjust the output from the effect of an error, so that it gets what we want. When changing the value of Kp, it will increase or decrease the error with deficiency, which will result in a steady state error. Ki will accumulate or reduce error that produce in the previous loop, and Kd will speed up the error or excite the error so that they can predict the future error so that they can speed up handling the error. And for the result we get is more like this. This one with the disturbance at time 2000 with final value is 70. The result of the adjusting Kp, Ki and Kd will stabilize the system so that it can correct the errors in the system. It can be seen that when the system is given a disturbance 2000 seconds, the PID will stabilize the system back to the desired value. Next. Here I will go into more detail about the topic that I discussed before. As I pointed out earlier, this is a form of the system control using PID that our group use. In the system that we create, we insert a disturbance value at the 2000 second with an additional value of 20, and the value we want is 70. So if we run here, we will get the result system like this. This disturbance that we add before, and PID system just neutralize it and become stable again. So if we change the value of Kp, Ki and Kd, we will get the result like that contain a steady state error like this. This is a steady state error that occurs when the PID system not the exact value to our system. So we need to adjust the value of Kp, Ki and Kd. If we make it more bigger, the value of Kp as 1.5, we will get the result like this. The steady state error become more smaller, so we need get the value of Kp more bigger again like this. We change the value of Kp before that become 2 again. We will get a steady state error that more small. So now we need to change the value of Ki because the steady state error have become small enough So if we change it to 0.5 to 0.1, we will get the result like this. A big of overshoot have occurred because the point of the value of KI we changed to 0.1. So we need try to make it bigger or make it small. If we make it bigger, it will be more more disaster. So we need make it more small. If we make it more small like this, we will get the result that the steady state error is become smaller again, and the overshoot becomes small too. So we need to adjust it more again. Back to the value we adjust before, and we get the result. Yeah, the steady state completely not completely gone, but it can't be seen anymore. So I think it's enough for the change of value of KI. Now we change the value of KD. For the value of KD, let's start from 50 because and for the result we get, look, the overshoot becomes more and more smaller, and the steady state error become more unnoticed. We need to adjust it more. Let's make it 100 now, and we play it again. The overshoot, yeah, it become more small again, but maybe it can be more steady. We need make it bigger again and make it more steady. So why not we just adjust it become 150, and yep, it has become more steady than before, and the disturbance is still get neutralized by system and become steady again. So I think it a successful treatment that we have changed on the value of KP, KI, and KD. Maybe that's enough for me for the detail of system PID that we need to explain. Thank you. For conclusion, Mbak Kayla, silahkan.
The conclusion that we get from the simulation is that in the water level control system in these two tanks, we conclude that the value of the PID system will regulate the speed of the water supply received by the tank so that it can reach the desired water level in tank 2. If there is a disturbance, the control system will restabilize the existing value with the required time. That's all for our presentation. Thank you for your attention. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam.